Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the global reporting system, the platform that aggregates, partitions, and serves analytical reports across every region, tenant, and time zone at planetary scale. We'll cover how large-scale platforms ingest data from heterogeneous sources, compute pre-aggregated rollups, enforce multi-tenant isolation, handle cross-region replication, and serve sub-second queries to millions of users worldwide. Whether you're preparing for a senior engineering interview or architecting a real reporting platform, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we are doing a complete deep dive into the global reporting system, the platform that aggregates, stores, and serves analytical reports across every region, tenant, and time zone for a large-scale data-driven organization. If you have ever wondered how companies like Uber, Airbnb, LinkedIn, or enterprise SaaS platforms deliver consistent, fresh, and accurate reports to millions of users worldwide, across dozens of data sources, in multiple languages, and under strict data residency laws, this video is for you. We will walk through the functional requirements, non-functional requirements, high-level architecture, end-to-end user journey, core models, low-level design, and the key trade-offs that come up in a senior system design interview. Whether you are prepping for a FANG-level interview or architecting a real reporting platform at scale, let us get into it. Here is the core problem. A global enterprise has hundreds of product lines, thousands of internal and external users, and data flowing in from every region on the planet. A finance analyst in Singapore wants a real-time revenue report. A marketing director in Berlin needs campaign performance broken down by country. A compliance officer in New York needs an audit trail of all data access. But behind the scenes, the situation is fragile. Data lives in regional data warehouses, transactional databases, event streams, and third-party APIs, all with different schemas, different update cadences, and different latency characteristics. A naive solution joins everything at query time and collapses under load. Users see stale numbers, slow dashboards, and inconsistent totals between reports. Cross-region replication creates data residency violations. Multi-tenant isolation breaks down. The business needs a purpose-built global reporting system that ingests, normalizes, aggregates, stores, and serves reports reliably, with fresh data, sub-second query response, and correct multi-tenant access control, at planetary scale. Let us walk through the functional requirements. First, the system must ingest data from heterogeneous sources, relational databases, event streams, data lakes, message queues, and third-party APIs, with both batch and streaming ingestion paths. Second, it must normalize and transform raw data into a unified reporting schema, applying business logic, currency conversion, time zone normalization, and data quality checks. Third, it must compute and store pre-aggregated rollups at multiple granularities, hourly, daily, weekly, monthly, partitioned by tenant, region, and dimension. Fourth, it must serve queries through a fast read API and an interactive query engine, supporting filtering, grouping, time range selection, and cross-dimension breakdowns. Fifth, it must support multi-tenant isolation so that one organization can never read another organization's data, even through indirect aggregation. Sixth, it must provide scheduled and on-demand report generation with export to PDF, CSV, and direct dashboard embedding. These 6 capabilities define a complete global reporting platform. Now the non-functional requirements. Data freshness is the most critical. Reports should reflect events that happened within the last few minutes for operational metrics, and within hours for heavy analytical aggregations. Query latency must be low. Pre-aggregated dashboard queries should complete in under 1 second, and ad hoc analytical queries should complete in under 30 seconds. The system must scale to petabytes of historical data and millions of daily active report consumers. Multi-region deployment is required for latency and data residency compliance. European user data must stay in European infrastructure, and APAC data must stay in APAC. The platform must be highly available with a target of 99.9% uptime. Consistency is important, but eventual consistency is acceptable for reporting. A report that is 10 seconds stale is far better than a report that is wrong. And the system must be secure, with row-level security, column masking for sensitive fields, and a full audit log of every report access. Here is the high-level system architecture. On the left, data producers emit events and records from application databases, event streams, external APIs, and offline uploads. These flow into a multi-region ingestion layer built on Kafka, with regional brokers ensuring data stays within its originating region. An Airflow-orchestrated ETL and ELT layer pulls from the ingestion bus and the data lake, applies transformations, runs data quality checks, and writes clean records into a partitioned columnar data warehouse. A rollup engine, running as scheduled Airflow DAGs, reads from the warehouse and computes pre-aggregated rollup tables at multiple time granularities and dimension cuts, storing results in ClickHouse for sub-second serving. A query federation layer using Presto allows ad-hoc analysts to query raw data in the data lake without impacting dashboard performance. The reporting API layer enforces multi-tenant access control, translates report requests into queries, caches results in Redis, and streams large exports to object storage. A cross-region replication service synchronizes metadata and global aggregates between regions while respecting data residency boundaries. The key metrics to memorize: cold data freshness lag, the time between an event occurring and it appearing in reports, target under 5 minutes for streaming paths and under 60 minutes for batch paths. Query P99 latency. Pre-aggregated queries should be under 1 second, ad-hoc queries under 30 seconds. Rollup coverage. The fraction of report dimensions that have pre-computed rollups available, target above 95%. Data quality rate. The percentage of ingested records that pass all validation checks, target above 99.5%. Cross-region replication lag. The delay for global aggregates to propagate across regions, target under 10 minutes. Report export success rate. The fraction of scheduled exports that complete successfully, target above 99%. And query cache hit rate. The fraction of API queries served from Redis cache, target above 70% to protect the ClickHouse cluster from redundant load. Let us trace the end-to-end user journey. A regional sales director at a global SaaS company opens the reporting dashboard on Monday morning. She selects last week as the time range and chooses her region, North America, as the filter. The dashboard instantly loads from pre-computed rollups in ClickHouse, rendering revenue by product line, customer segment, and sales rep in under 500 milliseconds. She notices one product line is down 15% week over week and drills down to the daily granularity. She sees the drop started on Thursday. She switches to an ad hoc query view, writes a Presto SQL query against the raw event data in the data lake, and identifies that a pricing change deployed on Thursday affected renewal events. She exports a PDF report for her leadership meeting. The export job runs asynchronously, and she receives a download link by email within 2 minutes. The entire journey from dashboard open to exported report takes less than 10 minutes. The core models and algorithms. Partitioning is the foundation. The raw event table is partitioned by region, tenant, and event date, so queries can skip irrelevant partitions entirely. Rollup computation works by materializing group by aggregations at coarser granularities, daily from hourly, weekly from daily, using idempotent Airflow tasks that can be safely retried. Dimension modeling uses a star schema, a central fact table with foreign keys into dimension tables for time, geography, product, and customer. Data freshness tracking uses watermarks. Each ingestion batch writes a high watermark timestamp, and the reporting API checks watermarks before serving to guarantee freshness SLAs. Multi-tenant isolation is enforced at 2 levels: row-level security in the serving layer and physical table or schema separation for the highest tier tenants. Cross-region aggregation uses a 2-phase approach. Local aggregates are computed per region, then a global aggregation job merges them, avoiding raw data transfer across borders. Rollup invalidation handles late-arriving data by tracking event time versus ingestion time and rerunning rollup tasks when late records fall within the rollup window. Now the low-level design deep dive. The rollup table schema is keyed by tenant identifier, region, metric name, time bucket, and a dimension hash covering all grouping columns. Each row stores the pre-aggregated value, the record count used in the aggregation, and the rollup generation timestamp. This schema supports additive merging. When late data arrives, the affected rollup rows can be updated by rerunning the rollup DAG for just the affected partition. The ClickHouse serving cluster uses a replicated merge tree table engine with per-tenant partitioning. Queries are rewritten by the API layer to enforce row-level security by appending tenant ID filters before execution. The query cache in Redis stores result sets keyed by a hash of the query parameters and the watermark timestamp, so a cache entry is automatically invalidated when the underlying data is refreshed. The Airflow DAG dependency graph ensures rollup tasks run only after the upstream ETL tasks have completed and the data quality gate has passed. For cross-region metadata synchronization, a lightweight event bus carries rollup completion events between regions, so the global aggregation job knows when all regional inputs are ready. Key takeaways for your interview. First, a global reporting system is fundamentally a read-optimized system. Invest heavily in pre-aggregated rollups, partitioning, and caching, because you will never win by querying raw data at scale. Second, always separate the streaming ingestion path from the batch aggregation path, and explain the trade-offs in data freshness, cost, and complexity. Third, multi-tenant isolation must be enforced at every layer: ingestion, storage, query rewriting, and API, not just at the application level. Fourth, cross-region replication is where data residency, compliance, and performance intersect. Design two-phase aggregation so raw data never crosses regional boundaries. Fifth, late-arriving data is inevitable in any distributed system. Your rollup design must handle recomputation gracefully using watermarks and idempotent tasks. If you can walk through these 5 points with confidence, you will demonstrate senior-level global systems thinking. That is it for the global reporting system. If this video helped you, please like and subscribe, and I will see you in the next one at Cloud Wizard. And that's a wrap on the global reporting system. We covered the full picture, from multi-source ingestion and Airflow orchestrated rollup pipelines, through ClickHouse serving, Presto ad-hoc queries, two-phase cross-region aggregation, and the low-level design of rollup table schemas, watermark tracking, and Redis query caching. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.